Good morning, friends. Today we discuss about Taylor series and Maclaurin series according to chapter expansion of functions. For example, our topics are Taylor series and Maclaurin series with solved examples, and how to find approximate value by Taylor series and Maclaurin series. Okay, for example, if you find out root of 25, then it is easy to find out root of 25, that is a 5. But when we discuss about suppose root 29, we have no value of root 29, so we find out approximate value of root 29. Okay, similarly sine 45 degree is 1 by root 2, but if we approximate the value of sine 44, we know that answer is between -1 and +1. But how to find sine 44 degree without using any scientific calci? Okay, so this is the Taylor series. If you have any function with a derivative of all orders throughout some interval contain a as an interior point, then the Taylor series of the function f about x minus a is, formula is fx is equal to f of a, means function value at the a, plus x minus a by 1 factorial, f dash a means derivative point, plus x minus a square by 2 factorial, f double dash a, plus x minus a cube by 3 factorial f triple dash a, and so on. So this is the formula to find out expansion of any function by Taylor series. Now in this formula, if a replaced by 0, then that is called Maclaurin series. So formula is like that: fx is equal to f of 0 plus, as a is equal to 0, so x by 1 factorial f dash 0 plus x square by 2 factorial f double dash 0 plus x cube by 3 factorial f triple dash 0, and so on. Means in a Taylor series, if we take a is equal to 0, so now it is converted into Maclaurin series. So Maclaurin series is Taylor series about x is equal to 0. We take first example. Find the Maclaurin series of the function e raised to x. Our function is e raised to x. Okay, and here given that Maclaurin series, so we apply the formula of Maclaurin series, that is fx is equal to like that f of 0 plus so on. Okay, so now our function is e raised to x. We find the value at the point 0 by the Maclaurin series. So f of 0 is e raised to 0. We know that 0 power of any number is 1 if it is not 0. So e raised to 0 is 1. Now we find out derivative of e raised to x. So derivative of e raised to x is e raised to x, and the value at the point 0, e raised to 0 is equal to 1. We find out double derivative of this, that is again e raised to x. So f double dash 0 is equal to e raised to 0 is equal to 1. So by the Maclaurin series, we have the formula fx is equal to f of 0 plus x upon 1 factorial f dash 0 plus x square by 2 factorial f double dash 0, and so on. Now value of f of x is according to data e raised to x, value of f0 is 1, value of f dash 0 is 1, and f double dash 0 is 1. So expansion of the function e raised to x is equal to 1 plus x upon 1 factorial plus x square by 2 factorial plus x cube by 3 factorial, and so on. So this is the expansion of e raised to x by the function by the Taylor series. Okay, so if question is how to find the value of e, if we take x is equal to 1 in the left side, so similarly right side is also replaced by 1. So if we take x is equal to 1, then e is equal to 1 plus 1 on 1 factorial plus 1 upon 2 factorial, and so on. Our next example, find the Maclaurin series of the another function sin x. So our function is sin x, value at the point 0, f of 0, sin 0 is 0. We find out derivative of sin x. So derivative of sin x is cos x. At the point 0, cos 0 is equal to 1. We find out double derivative. Cos x derivative is minus sin x. F double dash 0 is equal to minus sin 0 is equal to 0. F triple dash x is equal to minus cos x. So now f triple dash 0 is equal to minus cos 0, that is minus 1. So means f0 is equal to 0, f dash 0 1, f double dash 0 0, f triple dash 0, that is minus 1. Now so by Maclaurin series, formula is as per fx is equal to f of 0 plus x upon 1 factorial f dash 0 plus x square by 2 factorial f triple double dash 0 and so on. Now we have f of x is equal to sin x, f0 is equal to 0, f dash 0 is equal to 1, f double dash 0 0 and f triple dash 0 is minus 1. Means when we take a f0 f double dash 0 means all second derivative are 0. That's why expansion of sin x is equal to x upon 1 factorial minus x cube by 3 factorial plus x raised to 5 by 5 factorial and so on. Means in a expansion of sin x we have only odd power term, and with the alternative series means plus minus and power of x is odd number. Our third example, find the Maclaurin series of cos x. So function is cos x, value at the point 0 cos 0 that is 1, f dash x is equal to minus sin x, f double dash 0 equal to minus sin 0 that is 0, f double dash x is equal to minus cos x, derivative of minus sin x is minus cos x, f double dash 0 minus cos 0, but value of cos 0 is 1, so now it is minus 1. Triple derivative of cos x minus cos x is sin x, because derivative of cos is minus sin, so minus converted to plus sin, and value at f triple dash 0 that is sin 0 is equal to 0. So again by Maclaurin series, this is the formula. Now fx is replaced by cos x. We have value of f0 that is 1, f dash 0 that is 0, f double dash 0 minus 1, f triple dash 0 0 means value are like 1 0 minus 1 0, 1 0 minus 1 0. So f0 is 1, f dash 0 is 0, f double dash 0 minus 1, f triple dash 0 0. So when we take odd power then value 0. So expansion of cos x is equal to 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial and so on, means all even power terms are present here. Okay. Similarly, if we take a fourth term, that will be minus x raised to 6 by 6 factorial without finding the value. Now example 4, find the Taylor series generated by. Okay, now we discuss about the Taylor series. Function is 1 by x at a is equal to 2. We know that this function is not defined for 0, but here point is given 2. fx is equal to 1 by x is equal to x raised to minus 1, because it is 1 by x. Now point is given 2, so we find the value at the point 2, so x replaced by 2. That's why we have f2 is equal to inverse of 2, that is 1 by 2. Now we find out derivative of this. Power of x is minus 1, so derivative minus 1 x raised to minus 1 minus 1, so now it is minus x raised to minus 2. Again we find the value at the point 2, so x replaced by 2 minus 2 raised to minus 2, that is minus 1 by 4. We find out double derivative of that, so minus plus 2 x raised to minus 3. We find the value at the point double derivative, that is 2 x replaced by 2, so 2 into 2 raised to minus 3, so answer is 1 by 4. We find out triple derivative, that is minus 6 x raised to minus 4, value at the point 2, that is minus 6 2 raised to minus 4, so answer is minus 3 by 8. So value of f of 2 is 1 by 2, f dash 2 is equal to minus 1 by 4, f double dash 2 that is 1 by 4, and f triple dash 2 at minus 3 by 8. So by Taylor series about x minus 2, formula f of x is equal to f of 2, as in the formula there is f of a, but here a is equal to 2 by the data, that's why a replaced by 2 in the formula, so fx is equal to f of 2 plus x minus 2 by 1 factorial f dash 2 plus x minus 2 square plus by 2 factorial f double dash 2 and so on. Now we put the value of like f of 2, f dash 2 and f double dash 2 and so on. Now for the previous slide, f of 2 is 1 by 2, f dash 2 is minus 1 by 4, and f double dash 2 is 1 by 4, and f triple dash 2 is minus 3 by 8. So now we put the value fx is equal to 1 by x, f2 is equal to 1 by 2, f dash 2 is minus 1 by 4, f double dash 2 is 1 by 4. So according to first term is 1 by 2. We know that 1 factorial is 1, so second term is x minus 2 divided by 4, and also minus sign is before that, and we know that 2 factorial is 2. So now the expansion of this is 1 by x is equal to 1 by 2 minus x minus 2 by 4 plus x minus 2 raised to 2 power by 8, and so on. So this is the expansion of 1 upon x in the power of x minus 2. Here we find out f of x. F of x is given, we find out derivative 1 by 1, and then we put the value at point 2, because given that find the expansion of fx by Taylor series in terms of x minus 2. Fifth example, find the Taylor series expansion of the function fx is equal to x cube minus 2x plus 4 at the point 2. Function is given x cube minus 2x plus 4. We find the value at the point 2, it is given in the data. We find the expansion at the point a is equal to 2. So as x is replaced by 2, so f of 2 is equal to 2 raised to 3, that is 8, minus 2 multiplied by 2, then it is minus 4 plus 4. So result gives us plus 8. We find out first derivative of this. So derivative of x cube, that is 3x square, minus derivative of 2x, that is 2, and derivative of 4 is 0. So f dash x is equal to 3x square minus 2. We find out derivative at the point 2, that is f dash 2 is equal to 12 minus 2. X replaced by 2, so square is 4, 3 is 12 minus 2. So result gives us 10. We find out double derivative of that, so 3 common, derivative of x square 2x, so f double dash x is equal to 6x. We find the value at the point 2, so f double dash 2 is equal to 6 2 is 12. F triple dash x is equal to 6, and the value at the point 2 is equal to 6, because 6x is not present in the right side, so 6 as it is. As in the function fx is equal to x cube minus 2x plus 4, power of x is 3, and this is polynomial function. So according to theorem from differentiation, we know that if power of x is n, and if it is polynomial, and therefore if we take n plus 1th derivative, then it is 0, means here power is 3. So if we take 4th derivative, then that is 0, and similarly so on, means the cube power is given, so 4th derivative 0, 5th derivative 0, and so on, means all the derivative after the 4th power are 0. So now in this expansion we have f2 is equal to 8, f dash 2 is equal to 10, f double dash 2 is equal to 12, and f triple dash 2 is equal to 6. So by Taylor series about the point x minus 2. This is the formula where a replaced by 2, fx is equal to f of 2 plus x minus 2 by 1 factorial f dash 2 plus x minus 2 square by 2 factorial f double dash 2, and so on. Now the polynomial is x cube minus 2x plus 4. Now the first term is f of 2. We know that value of f2 is equal to 8, f dash 2 is equal to 10, f double dash 2 is equal to 12, and f triple dash 2 is equal to 6. So fx is equal to f of 2, that is 8, plus x minus 2 by 1 factorial, value of f dash 2 is 10, plus x minus 2 square by 2 factorial, f double dash 2 is 12, plus x minus 2 cube by 3 factorial into 6, plus all the terms after third power are 0, because we know that polynomial is 3 power, so fourth derivative are 0. Now we simplify this first term as it is. In the second term 1 factorial is 1, so there is no change, so answer is 10 into x minus 2. In the third term, 2 factorial is 2, so 12 by 2 gives us 6. In our fourth term, 3 factorial is 6, so 6 is cancelled. So now answer is x cube minus 2x plus 4 is equal to 8 plus 10 into x minus 2 plus 6 into x minus 2 square plus x minus 2 raised to power 3. Okay, so this is the expansion of x cube minus 2x plus 4 in the power of x minus 2, where answer is 8 plus 10 into x minus 2 plus 6 into x minus 2 cube plus x minus 2 raised to power 3. Okay, and then the other simplification, how to verify this? If we expand the right side, means x minus 2 multiplied by 10, we take x minus 2 square multiplied by 6 and x minus 2 raised to 3, then we have the left side, that is x cube minus 2x plus 4. Same type, same example, find the Taylor series expansion of the function fx is equal to x raised to 4 plus x square plus 1 at the point a is equal to minus 2. In our previous two examples, we take a is positive number. Now in this example, we take a is negative. Okay, so function is fx is equal to x raised to 4 plus x square plus 1. Point is minus 2, so we find the value at the point minus 2. So f of minus 2 x raised to 4, so minus 2 raised to 4 is 16, minus 2 square is 4 and plus 1, so result 21, means f of 2 minus 20, f of minus 2 is equal to 21. We find the first derivative of this, x raised to 4 derivative 4x cube, x square derivative 2x. So value at the point minus 2, f dash minus 2 is equal to 4 into minus 8, x raised to 3 is there, so minus 2 raised to 3 is minus 8, so 4 into minus 8 plus 2 into minus 2, so 4 into minus 8 minus 32, minus 32 minus 4, result minus 36. We find out double derivative of this, so derivative of x cube is 3x square, but 4 in multiplication, so result 12x square plus derivative of 2x is 2. So now f double dash x is equal to 12x square plus 2. Now the value is minus 2, so we put the value x is equal to minus 2. So f